because I was able to go to the International Biology Olympiad last year in Vietnam, and the US as a whole did pretty well, and I love talking about biology and learning and all that kind of good stuff, so here I am talking about biology and learning. Okay, so before we start out, obviously this presentation is going to have a biology-centered focus to it, as I did go to the International Biology Olympiad, not the Math Olympiad or Physics Olympiad, so we're going to talk a bit about biology to start out. So how do we, a lot of you, I know, a lot of you are in high school, some of you are in junior high, so how many of you have experience with biology? Like, good amount? One person? Good job, Angela, nice. Okay, well for those of you who have no idea what biology is the study of life. It has a lot of different components, a lot of different really cool things. So this is really blurred, but here's like a protein, it's pretty cool, kind of model of protein. There's a worm, this is called a roundworm, it's only 1 millimeter long. Over here you have actually game theory, which is a really cool, interesting subfacet of biology, which we set the rules and try to assume that every single player is going to want the best consequences. And that's really cool. So here you have food, we all like food, that's biology, and here are people, that's also biology. So great. To start out, we've got a good idea of what biology actually is. Now, why do we study biology? What are the important things about biology? I'll get to more of that later, but of course, you already know we have diseases like cancer, malaria, cholera that we're all trying to fight against. And of course, the vaccinations have become a problem again with diseases that are reappearing, such as smallpox. All these sorts of things deal with biology and why biology is an important science today. Okay, so to start off, we're going to talk about the USA Biology Olympiad, which is the prior step to the International Biology Olympiad. I'm sure a lot of you have heard of the competitions like AMC. AMC is a good example, possibly USNCO, which is the USA Chemistry Finals. This is the Biology Olympiad, in which you take a couple of preliminary tests, and then once you place in the top 20 of those, you get to go to this really fun 2-week-long camp at some university in the United States. That sounds pretty exciting. And in fact, this is one of the most exciting parts of this entire thing. You getting to go to this really cool university, really dedicated teachers and TAs, and you get to learn biology or whatever your subject field may be, along with 19 other really motivated students. So at this training camp, we train to prepare for the IBO, which is the International Biology Olympiad, as I've said. And I'm sure you guys are aware of the Olympics, basically the same thing. You got lots of countries, they send people there, and you try to win. So bring pride to your country. All right. More pictures of the USA Biology Olympiad. See here we have some lab work over here in the fields, and this really nice lecture room. It's very green in this picture. Also, we have the 20 finalists here after the award ceremony. Again, it's a really exciting experience. You get to learn so much biology, but more importantly, you get to meet so many incredibly dedicated people. You have every single student in there work just as hard as you to get to the top 20. Every teacher, their esteemed professor, researcher, all that kind of good stuff. So, as I will touch on later, the finals camp for all of these Olympiad competitions are incredibly good goal to shoot for, and it's incredibly fulfilling even if you don't make it to the international stage. But if you do make it to the international stage, you get to experience stuff like this, which is the IBO in Vietnam. This is the 27th IBO, and there are about 65 countries that went, 3 other spectator countries. You have countries like Singapore, Malaysia, China, Japan, Korea, Mongolia, pretty sure. And you also have some other countries like the US, Finland, Norway, Canada, and you get to this amount of people with all the competitors and guides and all that good stuff. Apart from the examinations, just like the Olympics, more of it so is meeting the people, meeting different cultures, all in one place, and all in one really short period of time. IBO lasts for about 7 days or 1 week. And that is, I believe, and most other people believe, is the great goal, is the great reason why we do IBO and stuff like that. You get to talk with competitors around the world that perhaps don't go to school the same time as you do, don't study the same subjects as you do, or don't play the same sports as you do. And you can mingle with them, acclimatize, talk with them, and realize how much more there is to the world. Of course, there's also the award ceremony after you take your tests. This is our Team USA over here. We have me, Peter Dunn, Barkey, and Bo and Jane. Well, 2 of them come from Indiana. Barkey comes from California. That's just a quick rundown. Over there, you see all the competitors line up on the stage. Really, really cool stuff. So to start out with, I told about biology, about the competitions. And generally, you can see a pretty common theme is it's really interesting, it's really cool, and really fun to go to and do these kinds of things. So how do we do these kinds of things? Of course, these are some more pictures. Actually, before we go to that, see this really nice picture over here. This is Great Britain, obviously covered the flag and all of its colonies, okay? So here's like America and South Africa and Canada. or Canada. Pretty funny. Okay. You can see they're trying to spell out Brexit, but it's also green, so it's pretty hard to see. All right. So again, the results. This is the overall summation of results from the USA when we first started participating in 2003 all the way until now, 2016. You see there are a lot of gold medals up there. USA, I think, the top Olympiad in the USA is the Biology Olympiad. And this is not because the people who do the other Olympiads are not as good. It's probably because we have a lot of resources for biology. The US has a lot of good labs, a lot of good universities, and also because a lot of other countries don't put as much time into Biology Olympiad. So that's why you see 4 gold medals, 4 gold medals, 3 gold medals, all this kind of great stuff. First place, third place, 7th place. It's incredibly good stuff. And I'm sure maybe some of you heard in the news that US also won the Math Olympiad for the 2nd time in a row, beat China. Yeah, that's pretty good. All right. Talking about China, here's the USA China Bio Olympiad initiative, which is actually starting next year. Obviously, since we're in the US right now, it's not going to be too much importance to us, but it's really interesting. The US teaming up with China to provide the Biology Olympiad test for all students. So, why do we exactly study biology? There's a lot of stuff that I'm sure you've heard about in colloquial sense, your day-to-day life, that deals with biology, and you know it deals with biology. Someone talks about cloning, someone talks about genes, someone talks about cancer, death, living, all that stuff, that's biology. And biology, of course, you probably don't think it's as fundamental as math, physics maybe, where we can just postulate a couple of things, say it out loud, write it down, we're good to go. But biology instead pertains to all of us. We're all living. We all live in this nature world where we must deal with biology and find out what we can do to manipulate biology to our advantage. Or perhaps not too much, but we can get to that later. So here's some examples. We have epigenetics. Who has heard of epigenetics in here? Let's be real. One guy. You're the man, dude. All right. Epigenetics, really solid. Very interesting topics. We've all heard of the nature-nurture debate. Are you born with the skills you have, or you grow and get these skills? Maybe the personality you have, the characteristics you have. Epigenetics is possibly a way for your daily activities, your behavior, to shape your genes and to shape what you pass on to your progeny. Now, it's also hotly debated, so we're not going to go too deep into there. We also have something called CRISPR-Cas. Not terribly important to know exactly the mechanism, which is up there, but essentially think of this. You had DNA. You have a gene you want to put in this DNA, and we can do it like this. It's very simple now. And with CRISPR-Cas, you'll see in the future, if you have a disease like cystic fibrosis, possibly even breast cancer, all these kinds of genetic diseases, we can fix that this easily by just putting new DNA into your DNA. It's that easy with CRISPR-Cas. Of course, I just skipped over a lot of steps, but that's the general gist of CRISPR-Cas. Moving on, we got longevity, we got cancer. We all know about cancer. We all know that we die at some age. With biology, perhaps we can find the key to unlocking why does our body age? Why are oxidative species so harmful to our body? Perhaps we can live longer. Perhaps we can live forever. Who knows? Bioremediation and GMO. So I'm sure even if you won't raise your hands, a lot of you have heard of what GMO is. GMO, genetically modified organisms. You probably eat some of them. You definitely don't want to eat some of them, or so you think. But really, we're just putting some genes that we like to see in the food we want to eat in order to eat the food that we want to eat. So, we got some strawberries, really big corn, disease-resistant corn that you guys are all eating right now anyway. And if you think GMO is bad for you, you can do some research online, check some stuff out. Definitely not good to be hopefully optimistic, but definitely not good as well to just shun away this idea of GMO. It's a very interesting topic we can delve into later, and it's definitely the key to solving the hunger crisis that still affects the world today, quite obviously. So, I talked a little bit about why we want to get here, why we want to go to the stages where we can meet so many people, and to do this, to talk more about how to get there, how did we do this, I want to talk about my journey through biology. Okay, so here I am, like 7th grade me, learning about biology in science class, I find it kind of boring, whatever. Moving on, get to 9th grade, learning about biology in science class, and the teacher shows you this diagram. I know it's really hard to see, but this is the mitochondria. Okay, does anyone know what the mitochondria is? Okay, what is the mitochondria? That's right, it's the powerhouse of the cell. Okay, here's the mitochondria. You have cellular respiration, and you get some magical molecule called ATP. So me, sitting in 9th grade biology, you're probably thinking, okay, cool, ATP is magical. And I'm kind of bored right now, don't really want to memorize this, would rather live my life as a freshman peacefully. And you probably don't like biology too much. And that's not biology's fault, it's more of our public education fault. We can go to that later. That's okay. Main point I want to share is the first step is you learn about this and you have no idea where this comes from, really. You know there's a step called the electron transport chain. Do you know what it does? No. Does it matter? Apparently not. But then you go to AP biology. Or maybe you study on your own for USABO. And you learn about this. And this is a picture straight from Campbell's. It's chemical osmosis. This is the driving mechanism for the electron transport chain. So don't be feared. This is a very simple concept. Just imagine we need energy currency for our bodies. ATP is like the dollars we spend. So how do we make the dollars? How do we mint the money? We take energy from electrons, move H+, we all know H+, hydrogen, acidic water, across this nice barrier. And then, because all this H+ is so concentrated, it wants to move back inside. It wants to come back in. And that wanting, for lack of a better term, is what generates our energy. That's what makes our ATP. This simple system is so fundamental to every single aerobic living organism today. Yet we don't really know about it if we don't go into biology. We think it's hard. We think it's weird. We look at that first step and I don't even want to touch the electron transport chain. But then when you go to here, look how simple, how fantastically elegant this process is. And that is not the process of human inventions, physicists sitting at a table for hundreds of hours trying to figure out a solution. This is the solution of millennia of evolution. And life came up with such a pristine, elegant solution that we can all understand. We can all conceptualize, and it's so simple to utilize. Finally, we have the third step, what I believe, in learning biology is perhaps you're undergraduate learning biochemistry, perhaps you're graduate learning biochemistry, and then you learn about this little guy, which is the enzyme, or the machine, that does make this ATP. So it's this guy right here, this guy is this guy. It has a lot of weird Greek letters on it, a lot of different symbols, a lot of different subunits. Too complicated to know, but when you delve into biology that deeply, you get a greater understanding. You can understand why these binding energies are so delicate, why each subunit is regulated as it is. You gain more appreciation for the delicate intricateness that makes all of this up. We don't even think about this from a day-to-day basis. If we did think about it, it's hard to think about it. It's hard to learn biology. Yet our bodies do this every single day. Each cell does this every single day, from bacteria to paramecium, anything. This is a good metaphor for what I believe to be the steps of learning biology. Perhaps the step of learning anything. You start out, perhaps you're confused, kind of frustrated, annoyed, why am I learning this? Is this really important? And then you move into a deeper level. You find, this is not as hard as I thought it was. This is not as arcane as I thought it was. It pertains to me, all of us, and I can gain inspiration from this. And finally, the third level, you reach mastery. You go into the intricate details. You find what makes life life. What makes any subject the way it is. That is the 3 steps of cellular respiration learning, and also 3 steps of learning any subject. So, I'm sure a lot of you came here to know how am I going to start telling my kid, or if you're the kid, how am I going to start studying for USABO or perhaps any other Olympiad? For my advice for USABO is to start with this magical textbook called Campbell's Biology. This is the 8th, 9th, and 10th edition. If you want, you can talk to me after, of course, ask any questions. Not too much difference between these editions if you really want to do this. We've got the 8th. The nice magnolia flower, that's the one I personally like the most. That's okay, whichever one you like. Also, so you have this website called studyoflife.org. Studyoflife.org is a really cool go-to website. If any of you know AOPS, art of problem solving, is basically that for biology. Lots of tutoring opportunities, lots of resources, tournaments, that kind of good stuff. This is a great starting point. I talked about Campbell Biology. That's basically a textbook. If you just read it through, understand it, enjoy it on your journey, then you'll get really, really quite far on this tournament, these competitions. Campbell's is definitely the best place to begin. It's not terribly difficult, but maybe it takes a while to get used to. That's my advice. So, let's go into more interesting stuff. Instead of just me giving you a to-do list in order to make it to an Olympiad, to make a goal, or to make your college admissions officer happy. Let's instead talk about learning. Why do we learn things? Why do we need to learn things? And why does school make us learn things if we don't want to learn things? Learning is not just about math, science, literature, social studies. Of course, learning happens in each of our lives, every single day. We talk to someone, find out something new. We act a different way, find out that habit works better. Learning is essential to us as a human being, as our human species, and we would not be where we are today if it were not for learning. But of course, I bring this up because school is not the greatest place that we have in our minds to learn. A lot of us don't wake up every day and be like, yes, I want to go to school today. I'm so excited to go to school today. I'm going to wake up at 4 a.m. to go to school today. That's usually not what we say. And school is generally viewed as a 7-hour place where I have to do a lot of busy work, learn a bunch of weird stuff that's not going to bother me later on when I want to be, say, an engineer and I'm learning freaking Shakespeare. But that's okay. Because we know that, we should know that learning deals with every subject. No matter what subject. You think you're learning language won't help you with math. But math is a language. The language of creativity and problem solving. You think you're learning physics. And why am I learning world history? World history gives you the insight into why we did things in the past. Where we get these concepts. What civilizations were so great enough to have these innovations in these mathematical fields. We have science, math, art, and music. All of these subjects are important. Not one of them is more important than the other. Not one of them should be treated lightly more than the other. But sometimes we have preferences, and that's okay. What I want to stress to you is that each one is important. And if you learn to love learning, then you'll find that your life just becomes that much easier. You'll improve that much quicker. You'll have more fun. You'll have more productive days. You'll find school a better place to be, and you'll have more time to do the things you want to do. Maybe you want to practice your instrument, hang out with friends, go for a run, all that kind of stuff. If you love to love learning, then you will indeed get that magical keystone in your life that will help you do all these sorts of cool things. So, just talk about school for a bit. Yeah, school. This is Seven Lakes High School. It's a great school. You know, I'm not gonna lie at all. It's a great school. My senior class has about 800, 750 kids. You know, has a lot of great teachers, a lot of really stellar teachers. Has a lot of great athletics, all that kind of good stuff. I could talk about the school for hours, and I'm sure you would not want to do that at all. So we're just gonna move on really quick. Anyways, annoyances goes along well with the school slide. We have a lot of things that annoy us in our day-to-day life that we think school gives us. Maybe our parents give to us the extra worksheets or anything. I need to practice the annoyances that we think we should not need to do. We don't want to do them, maybe. Annoyances are really, my belief is, just in your mind. A lot of this stuff, of course, if you give to someone else, they might find it more exciting. Someone else may like school more than you do. Someone else may like playing the flute more than you do. But in your mind, you don't like doing these things. My advice on this topic is to find those annoyances. Why do these things frustrate me? Why do I not like doing these things? Pinpoint the reasons, and then change your mindset. Now this theme of changing mindsets, this theme of loving to learn, is going to be very common throughout this presentation. And it does, in fact, relate very much so to USABO, to IBO, to getting to these competitions, getting to the college you want to. These are the things you need to do, rather than just, oh, I need to get the 2400, the 1600, whatever. On my SATs, gotta get that ACT score, all these scores, all these GPA, all these extracurriculars. Rather than focusing on what you need to do, focus on what you should be in order to do the things that you need to do. Grades, just alluded to grades. So grades, I'm sure not a lot of us like grades, and if you like grades right now, you're probably not gonna like grades after you fail your calculus test or something. But we have grades, and they're necessary. We can't just have a teacher say, you know, oh, my student is doing very well in Calculus BC, you should accept him to your college. And we have another student from, I don't know, California, oh, my student is also doing very well. And obviously no one's going to know what very well means. And we all know that 5 is greater than 4, so why not put some numbers into our grading system? You know, grades, a lot of great people, CGP grades said before, grades measure how well you do on assessments. Grades do not measure how well you learn, how much you have learned. But they're related. But directly, grades measure how much you put toward that correct assessment practice. My advice on this topic, and this is not supposed to be a seminar where I just straight up dish out advice, but generally, grades are not a thing you really need to worry about. This goes along in life in general. You're going to have a lot of things that show up, and you know they're not true. You know you're good at math, but you got an 85. You know, that kind of stuff. That stuff should not mean you yourself, your personality, your mindset has to be degraded. It does not mean you're a bad person. It just means on that assessment, it just went poorly. And that does not reflect, really, who you internally are. So finally, I just talked about how grades are not that important. So how are we going to measure ourselves? How are we going to find out how much we can do if we're not going to look toward grades? Grades, not as good as competitions. Competitions come in a lot of different forms. You play in the orchestra, play in the band, you have region, you have all-state competitions like concerto competitions. But if you want to focus on purely academic competitions, You have lots of different choices in the US. It's a great country for all those kind of competitions. So if you're in junior high, you probably heard of math counts, probably like doing math counts. The AMC, of course, right up there, MAA. If you're in high school, probably heard, and junior high, of course, you probably heard of Science Olympiad, very strong in this Katy area. And all these other competitions. You got the USA Biology Olympiad, NACLO, which is the USA Linguistics Olympiad, which is a real thing. The US Physics Team, USAAO, which stands for United States Astronomy and Astrophysics Olympiad. Astronomy, cool. And then USINCO, like I said earlier, the Chemistry Olympiad. And then, of course, the Earth Science Olympiad, forgot about that one real quick. So, a lot of Olympiads, a lot of things for you to choose from. Of course, other competitions, track and field, basketball, all the sports, all these things that push you to find out what you can do and make you find out that indeed you can do more than you think what you can do. These competitions exist for that reason. Of course, I myself have participated in USA Bio Olympiad and Science Olympiad a lot. I really do love those competitions. They're a great experience, great way to meet new people, and great way to push yourself to find out what you can truly do. All right. So I said the word advice like 6 times prior, and I don't really enjoy this word advice. A lot of advice does not apply to other situations. Some advice is difficult to apply. Some advice is so obvious, you think, why is this person even telling me? It's like, you should be a happy person. Well, no, thank you. Yeah, okay. Should be a sad person? Okay. You know, this kind of advice, it's not too easy to give. So the advice, the one line, one sentence that would best fit this advice role is that advice does not apply to every situation. Advice is not absolute. Life is not binary thinking. It's not a line you can draw in the sand and figure out yes or no. It's malleable, ductile. You can push and pull. There are not some set rules in life that will get you through every situation. And that is, as we know, the point of life. We're not here to follow the rules of games. We're here to find our own way. We're here to find our own methods that work for us in certain situations. So when someone tells you it's probably a good idea to always make a decision quickly, tell them, yeah, maybe, unless I try to get into a marriage when I'm under 20, and that would be a bad decision. You know. On failure. So failure comes a lot when you're trying to shoot for success. A lot. My sophomore year, which is when I started doing Biology Olympiad, I got past the open stage, took the semifinal stage, which is the stage right before the 20-finalist stage, and then I proceeded to miss the cutoff by like 8 points. That's a pretty good example of failure. Other good examples of failure don't have to do with you individually, your competitions. Maybe countries failing as a whole. Maybe you disagree, you think you're disappointed in the lack of competent political discourse in our country. That could be a failure. You know, all these sorts of things. Perhaps you forgot, you left your pencil in the classroom and you lost it. That's a failure. All the things when we put the connotation of failure next to these things, we're immediately a little bit disappointed, a little bit sad. We think, I don't want to be a failure. I want to be a person full of success. But failure should not be treated in this negative way. Failure and success are not opposites. Failure and success are almost, in fact, the same entity. Success cannot come without failure. You need to find out what you did wrong. Finding out what you did wrong will help you do what's right. Now, some other examples of failure. This year at the International Biology Olympiad, we got 3 gold medals and 1 silver medal, which is amazing. 3 gold medals and 1 silver medal. We're the 4th best country in the world as of now in biology. China, Taiwan, and Singapore. Singapore, all 3 of those got all 4 gold medals, and 3 gold, 1 silver. It's great, but usually U.S. is the best at biology. So this is kind of a rough point, kind of a little salty point for the U.S. people right now. So this failure aspect, of course, we can apply to this as well. We know we'll move on. Next year, our biology team will be even stronger. We'll beat China. Okay, so about failure and success, competitions, grades, school. Thomas, how do you go to USA Biology Olympiad? That shouldn't be the main point of what I'm trying to say here. What I'm trying to say is, how can we improve, the audience, me, society as a whole, how can we improve to make this world a better place? What are the problems that face us today? How can we fix these problems? Can I fix these problems as one individual in the world of 7 billion people? Can you? The answer is yes, you can. And it's not something like, oh, you need to go win a Nobel Prize, so you can donate all your money to a charity in South Asia. That's not the kind of thing I'm talking about. Every one of us has the ability to change our thoughts. Thoughts are perhaps the only thing completely within our control. We can choose to be positive. We can choose to think good things about other people. We can choose to have a strong, ameliorative mindset that will benefit others whenever we talk to them, whenever we're around them. Yeah, there are a lot of problems in the world today. We got global warming. If any of you don't think global warming / climate change is a real thing, feel free to talk to me after. We can discuss that. We have scanning computers. That's also a problem. All right. Yes, please can. Thank you. Okay. So we have global warming. This is carbon dioxide emissions. This is also just by China. This is the ocean acidification right here. Lots of CO2, increases in acidity, decreases in pH, and all of your really, really pretty coral reefs are now dead. That would be a very sad life. Over there we see the more just this decrease in glacial ice. Now, we all know what glaciers are. They're big masses of ice. They don't move a lot, so we probably think they're not important. But once they all melt, Canada will be submerged, so that's not good. About 100 meters increase in sea level right there. More things that are important, more things that are quite saddening to see. You see this beach coastal erosion. Who decided to build a building right next to the water? Not no one, because we built a building probably about 100, 200 meters from the water, and then it all got eroded. So this building is in danger. This building is also in danger. And this is actually a pretty big problem happening in Louisiana, Florida, all this kind of stuff. And yeah, it's a problem we probably don't think about compared to these other important problems. Species extinction and human population. For those of you who aren't aware, we've had 5 mass extinctions in the Earth's 4.6 billion year history. 5 mass extinctions, okay? That's a mass extinction where 90% of the species died. 78% of the species died. Now, us humans are about to be awarded the title of getting the 6th mass extinction. What a great title. Now, I will be very clear here. We are not on any level the same magnitude as the extinctions that have occurred in the past. But it's a very definite possibility. And saying that is not oh, we got out of jail free card. Do you want an extinction level like this, the Permian Triassic extinction? That would humans would not survive that. The Earth pretty much wouldn't survive that. That would be fun, really not fun at all ending to the legacy we leave behind. So finally, I'm talking about a lot of problems, and if you look for problems, all you find are problems. Problems in climate, problems in discourse, problems in your everyday life, problems like, why is my teacher doing this? Interacting with humans, what problems? But really, what we should focus on rather than problems are what we can do to solve these problems. How can we be the one in the world to change the world? If not you, then who? You might know that quote, Dan Brown's Inferno. If not you, then who? If not now, then when? So probably you see here the election of 2016, which is mercifully about to be over in about 2 months. Which is great. I'm not going to talk too much about politics here, but let's just say that it is the most interesting turnout we've had for like 80 years. There you go. This is a more serious note. Syrian refugee crisis, which I am sure you've all heard about in the radio, day-to-day talk. You've heard about it, you've moved on. We're not the ones to deal with the Syrian refugee crisis. We live in Katy, Texas. But indeed, this is a problem. It's not we and them, it's us. We as a human population don't exist in one country, one continent. We're one whole, and this is a problem. When will this problem be solved? Very, very, very difficult to say. This problem, how much land are we using per person? So me as a middle upper class citizen in the United States, I'm using about 10 hectares resources. Now 10 hectares, this is the sustainable resource use right here. It's about 2 hectares, okay? So we're all the way over here, good job USA, at 10 hectares. That's not a good thing, but why I show you these things is because we, in our families, in our community, we can help change these things. We don't have to be using so much water. We can carpool. We can save resources. We can recycle. For the election, we don't have to dive deep into crazy flame wars and just insult other people. We can have natural, competent, intelligent political discourse. Oh, is that a policy you're thinking about? Let me tell you about what I think my policy. That kind of real adult stuff. That kind of stuff. The Syrian refugee crisis not much we can do directly, but it is a problem. This problem, to be grateful, is, we don't have massive wars killing off 60 million people in a period of 5 years anymore. But this is one of the remaining problems that deal with war, that deal with human conflict. By changing our mindsets, we can indeed help these people. We can help our community, our family, and the earth as a whole. This quote comes from Campus chapter 56. It's basically the second to last sentence in the entire book. We are most likely to protect what we appreciate. We are most likely to appreciate what we understand. I just told you about what we can do to help us make this world a better place, what the problems are. Before that, I told you about biology, all this kind of stuff, and learning, what we mean when we say learning, why learning is important. When we appreciate learning, when we understand what learning means to all of us, what it can give us, we're most likely to protect the earth we live on and all of the resources we have today. Learning will get us through this crisis. Learning will help you change your mindset, give you a broader world view, give you more culture knowledge, more social knowledge, more scientific knowledge, so you can make these educated decisions, these political decisions, talking to your friends, seeing two different viewpoints, perhaps you and your child's, seeing this, moving on, and realizing that advice is not a one-time, you use this, give all situation. It's a line so blurred that it's quite just a splash of paint on the floor. We don't exist in a two-part world where one side says yes and the other side says no. Through learning, we will be able to change our mindsets, to be able to construct new innovations, go further in relationships, make this world a better place. Finally, this quote is not some book's quote, a very old quote. This is in Latin. Per aspera ad astra. This quote means, through hardship to the stars. What a nice quote. In 4 words, through hardship to the stars. That symbolizes a lot of what I've said today, and probably what you're thinking about today, what you've been thinking about, what our society needs, and how we can get there through the hardship to the stars. It's not going to be an easy journey. Humans right now are on the brink of choosing the correct decision and the wrong decision. We're on the brink of saving the environment or grooming into disaster in a period of, say, 500 years. We would be the quickest species, the only species to completely destroy the earth. Or we can be the society that stands up, that says we must put regulations, we must give the public the knowledge that global warming, climate change is a real thing. We must stand up for positive political discourse, for learning in schools, for the importance of education. That is the stars for us. So, thank you all for listening. Before we end, and I'm sure we have about 30 minutes, so if anyone has any questions, feel free to ask right now. It'd be an awesome time. If you want to wait after and ask, that'd be awesome. So, any questions right now? I'm sure a lot of you have some questions. No questions? Any questions at all? Yeah, what's up?
So what did the USA biology team, what did the university do?
Oh, that's a good question. So what university do we train at? This year we trained at Marymount University for 2 weeks. It's in Virginia, Arlington, very close to DC. Usually it's at Purdue, and in the next few years we'll be going to a different university. Yep. Yeah.
When we talk about time management, that's
yeah.
a problem.
Yeah. That's a good question. Through time management, I get the question a lot. A lot of people have this question. What do I do during my day to make me more effective, to make myself get the work done and get the sleep I need? You can try that. Okay. You got a lot of work in school. You've got a lot of extracurricular work. You've probably got a lot of instruments, maybe sports you want to practice. The key here, when you're doing anything, make sure you're doing it as best as you can. Will Smith said this quote, "You knock the brick wall someday." There's a friend of Will Smith, I think it was his son. He knocked the brick wall down. Not sure how he did it, but he did. The brick wall is now broken. Will Smith tells his son, you need to fix the brick wall. And the son's like, how am I supposed to fix this? This will take forever. There's so many bricks that I have to pick each one up, put each one individually. He says, Will Smith, then you better make sure you put each brick on as perfectly as you can. Whenever you do anything, you're listening in a class lecture, you focus, you do what the work the teacher says, you do the homework perhaps in the class, put your effort into it. Doing homework, kind of time consuming. My advice for that, do it in class, mostly if you can. It's a great idea. There's a lot of busy work, I'm sorry. Do it in class. It's a project, try to do it really quick at home. Don't work while being on Facebook, that's a really bad idea. Or your Snapchat, or Instagram, or messages, or whatever. Just do your work. Focus and tell yourself, okay, if I do this work right now, my life will be so much better. Then you'll get faster, you'll be able to work harder, work quicker, and you'll be able to practice more effectively. So my advice for time management is don't have distractions while working, and don't do things that are solely there to waste your time, or that you don't gain a lot of benefit from. So how many of you play video games? Like, let's seriously be honest, because last time I asked this question about nobody. League of Legends, yes, Lotus, Mike, StarCraft 2, yeah, what are you playing?
An online
What's it called?
politics.
Okay, that's nice. My point being here is I used to play a lot of video games when I was in 9th grade. And this is not a speech for all you parents out there to go home and tell your children to not play video games and say it's because Thomas said so. Don't do that, okay? But video games, they do help you a lot. They do give you some idea of control, quick movement, decision making. But also, video games are not going to help you really with biology class, with physics class. And once you start learning, once you like the improvement that learning and homework gives to you, then you'll find out that video games are kind of a fake goal. They make you feel good about yourself. But improving and learning also makes you feel good about yourself. And that gives you real, tangible things you can do with it. So if you realize that, you'll be able to quit video games pretty easily, which I did. So, but if not, maybe you'll be the next, I don't know, CLO or something. Yeah. Any other questions? Yeah, you.
So what do you do in biology Olympiad?
Okay, good question. So biology Olympiad is an individual test-taking format. So first test you have is called open exam. 50 questions, 50 multiple choice, 50 minutes. You pass that, get in the top 10%, you move on to the semifinal exam. Semifinal exam, a bit longer, it's 2 hours. Free response, multiple choice, and multiple choice. If you score in the top 20 of that, you go to the camp. Now the camp has about 10 days preparation. You get genetics, you get game theory, molecular biology, all that kind of good stuff. Then you take a 6-hour-long practical split up into 4 parts and a 3-hour-long theoretical exam. You place in the top 4 of that, and you get to go to IBO. Now IBO, you have, again, 6-hour practical split into 4 sections, and the theoretical, 6 hours split into 3 hours each. Then you score in top 10% of that, you get a gold medal. 20% after that, silver medal, 30% after that, bronze medal, and 10% after that, the honor merit certificate thing. I said the practical thing to a couple people before, they find it kind of intimidating, but when you're in that room trying to do a test, a really freaking hard test, in an hour and a half, it just flies by. Same with the theoretical and all that kind of stuff. So that's the process, that's how you get through it. Really fun process if anyone want to try it. Alright, anyone else? Yeah?
Okay, which college is your dream college?
In college, good question. So right now, I will like to be deciding between MIT, Harvard, and Stanford with a preference toward MIT because I really like their atmosphere, their notion of trying to go for curiosity for things that we've not done before, to change up our habits, to see what works best. That's what I like about MIT. But all 3 of those are really great. I would love to go to any of them. Yeah. You have a question?
Can you tell actually people what did you do during the week?
Okay, so week during the IBO, that's kind of interesting. So for IBO, you arrive there, you get your guide, who is someone who knows the native language. We had Xiong. He was an awesome guy, spoke really good English and Vietnamese, and was also an International Biology Olympiad gold medalist. Yeah. So then you have one day, you get to explore the surroundings. They'll probably put you on an excursion, something like that. Then you have the opening ceremony. After the opening ceremony, you go and look at the lab equipment the next day to get yourself familiarized. The day after that, you take the practical exam. After that, you have a break day. We went to the pottery village, got to do really a lot of cool stuff. Day after that, take the theoretical exam. And then finally after that, you're done. So you get another day of just free. We got to go to Xiong, really nice scenery, really nice landscape. After that, you have a little bit more excursions, private shopping, then you have the closing ceremony. So that's generally the week of IBO. And of course, each country has a little bit of different schedules. Some of them arrive early, some of them leave late, all that kind of good stuff. That experience is seriously once in a lifetime. Just straight up here. You are in an environment with 65, 68 other countries all at one time. Like, when are you ever going to get that? And each of you can talk about what you like. Perhaps you can't talk to them. For example, there are some teams, such as the Ukraine team, kind of hard to talk because they mostly speak Ukrainian and Russian, but still, what an experience to be in that room, in that environment, that city, with so many different people all at once. That is, I believe, the best part of the IBO.
So where's it gonna be next year?
Next year, IBO will be held in someplace slightly less exciting, Coventry, United Kingdom, from July 23rd to July 30th. But UK will make some pretty good tests and a really good schedule, so definitely shoot for it if you want to. Anyone else? Yeah.
So you said that you participated in Science Olympiad.
Yeah.
What groups do you participate in?
Okay, do you go to Vector?
Yes.
What grade are you in? What's your name? Jack?
Yes.
Okay. So this is your first year doing Science Olympiad?
Yes.
Alright, good question. I started in Science Olympiad when I was in 7th grade. If I were to give you the list of all the events I've done, that'd probably take forever. But just a general idea, I do earth science and biology events. So, in junior high, I did dynamic planet, a little bit of disease detected, sounds and music, metric mastery, meteorology, and other stuff, such as EX design. Then I move on, went into high school. I actually went back to 9th grade. 10th grade, I did events, astronomy, dynamic planet, geologic mapping, and cell biology. And then the next year, I did astronomy, dynamic planet, geomapping, cell biology, and fossils at nationals. Ended up doing really, actually quite well. So that was a really fun time. So yeah, if you need advice, just let me know. I'll see you guys better with this year. Yeah. Anyone else? Yeah. Good question. I don't. I kind of do sports. I do off-campus PE, which means I play tennis 5 hours a week, which is like, if you call it playing tennis, I guess it's a sport, but I'm kind of bad, so there you go. But I do practice a lot of cello. I kind of was a sport going. Anyone else? Really burning questions on your mind that you perhaps want to ask me afterward, or you